Greetings dear children. So today we are going to start with this chapter solutions. It is one of the important chapters from chemistry. Let's get directly into the definition of what is the meaning of the word solution. So solution is a homogeneous mixture of two or more pure substances. So the most important words over here are homogeneous, and it must essentially have two substances minimum, or we can have more also, and they have to be pure, whose composition and properties are uniform throughout. So now this is like, for example, we have these solutions in front of you, and if I talk about the first container in this, there is a solution, and if I take the portion A of this liquid and the portion B of this liquid, then the percentage of the solute should be same in the part A and the part B. So if the composition of the part A is, let's say, 2%, then the percentage of B also should be 2%. If it is not 2%, then we will say they are not homogeneous and it is not a solution. So when I use this word solute, we all know what is the meaning of solute from lower classes. We have been studying this. Let's quickly delve into the definitions. Solute is the first. It is the component which is present in the smaller quantity, and solvent is the component which is present in the largest quantity, and it determines the physical state of the solution, right? Then binary solution. So what is a binary solution? As you can see, the word is binary, which means it is made up of two components. So it is a solution which contains only two components. So these were some simple definitions. Let's understand why this chapter is important in our daily life. Now in this whole chapter you will be talking about various things. Let's see, the first example over here is alloys. So basically, what is an alloy? Alloy is a mixture of two or more than two elements, out of which one element essentially has to be a metal. So naturally, along with that metal you can mix any other component. Mostly we use non-metals, or sometimes we can also use metals. So there is no hard and fast rule. So alloy is a blend or a mixture of two or more than two elements. One of it essentially has to be a metal, compulsorily. So at least remember one or two examples from your science. Example over here we are taking is brass. So brass is an alloy of copper and zinc. So it is a solution, solid solution. It's a homogeneous mixture. Bronze is another alloy which is a mixture of copper and tin metal, and German silver is also made up of three metals, copper, zinc and nickel. So in this way we talk that alloys are so important for all of us, and it is a type of solution. Then the next is fluoride levels in toothpaste. So in this way we talk about an important concept that is called as solution, the concentration. So in this chapter you will also understand that how do you express the concentration of solutions. So here a very important unit has been used, that is parts per million. You are going to express the concentration of very dilute solutions by using this unit called as parts per million, which means if I say that the fluoride content in toothpaste is 1 part per million, it means that there will be, let's say, 1 gram of fluoride in 10 raised to 6 grams of the toothpaste. So in this manner you are going to understand that how this chapter gives me knowledge of how to express the concentration, that is the amount of solute in different types of solutions. The best example taken over here is of a toothpaste where there is fluoride, and they also talk about what happens if the concentration is 1 ppm. So it is good for our teeth, it prevents tooth decay. But if the percentage goes beyond 1, it reaches 1.5 ppm, it can cause the mottling of teeth, which means the teeth becomes yellow. Thirdly, they also talk about if the concentration becomes higher than 1.5, it becomes a rat poison. So this is how we understand the importance of expressing the concentration. Also they talk about injections when the doctors inject fluid inside the body. Intravenous, which means in the body blood vessel, in the veins, they are giving us injections. So when the intravenous injections are given to you, care is taken that the concentration of the liquid which is in the injection matches with the blood plasma ionic concentration. So the blood plasma ionic concentration is 0.9%, and hence whatever injections are given to you, the concentration of that fluid also should be 0.9%. Otherwise it can cause lot of issues. It can even cause death. I'm writing a word, isotonic solutions which are having the same concentration. So remember, the fluid injected in the body should be isotonic with the blood plasma. And lastly, children, you all know our body consists of almost 70% of water. Okay, now this water means it will contain 70% will also have some blood plasma component and many other extracellular and intracellular fluid which we are not interested right now from the chemistry point of view. So the only answer which we have here is how solutions are important for carrying out various metabolic processes inside the body. As we know, human body comprises of 70% of water. So let's move ahead to the next topic. What will you learn from this chapter? A very quick guide to the major ideas and sequence. So dear children, you're going to study the first thing, that is describe the formation of different types of solutions. Okay, what are the various types of solutions? Also you will understand how to express the concentrations in different units, which we have already started by when I used the unit as parts per million. Okay, like weight by weight percent, volume by volume percent, ppm, molarity, molality and mole fraction. So what are these particular things mentioned over here? These are the units. So when somebody decides that he or she has to prepare a solution, what concentration units is she going to or he going to use? So they are going to use any of these units depending upon their convenience and the solution's nature. After that you study the laws, Henry's law, Raoult's law, important for exam. You'll also understand what is an ideal solution, what is a non-ideal solution, and also you will study the difference between them. You'll also understand the deviations from Raoult's law, positive deviation, negative deviation, and describe all the properties, colligative properties, and determine the molar masses of the solutes. Finally, we'll be talking about explaining the abnormal colligative properties using a very important term called as Van't Hoff factor. So these were our objectives. Okay, objectives will help us to understand how we are going to go about. So let's directly come to the first topic, types of solutions. We already discussed what is the definition of solution. So solution is a homogeneous, which means uniform composition. What is the meaning of homogeneous? The composition is uniform throughout. Okay, you will see as I took the example of that beaker full of solution. Okay, let's take this example over here. So if I take this red colored solution and somebody takes this part B and somebody takes this part C, then the property of sample B and sample C should be same physically, chemically. So that is a uniform. A solution is a homogeneous mixture of two or more components. We already discussed the meaning of two means binary. The component which is present in the largest amount, the more quantity, is going to be called as a solvent, and the one which is present in the less quantity can be called as solute. Now let's go to some best examples. There are total 9 types of solutions in this world based upon the physical state of the solution. Alright, so what is the criteria? What is the criterion? The criterion for the classification is the state, the physical state of the solution, whether it is a solid, whether it is a liquid, or it is a gas. As we all know, there are 3 states generally commonly known: solid, liquid and gas. So if the solvent is solid, it is solid solution. If the solvent is liquid, it is a liquid solution. If the solvent is gas, it is a gaseous solution. Now some examples are given over here. Solvent. Let's look at this. If I told you the solvent is gas and you dissolve another gas in that, it becomes a complete gaseous solution. Like for example, oxygen plus nitrogen mixture, where nitrogen is in 78% concentration, whereas this will be 21%. Apart from that, there will be other gases like moisture, CO2, noble gases, etc. So in this particular case, you can say that the one which is present in the larger quantity, nitrogen, is called as the solvent and oxygen will be the solute. The second example is in gas, in the air. For example, if you just take chloroform, it will start evaporating and that can get automatically suspended in the air. So liquid in gas example is chloroform, vapor suspended in nitrogen. Similarly, when you burn camphor, automatically, or you don't burn, you just you don't have to burn it, you just keep it, it will automatically change from solid state to the gaseous state, and that gas will actually get uniformly distributed in the air. So that will also become a gaseous solution. So generally these two are not that true solutions, okay, because in these two examples we can see that the particular liquid is not liquid anymore and that particular solid is not solid anymore. Basically they have got converted into a gas by means of evaporation or by means of sublimation. Let's come to the second example. The second types of solutions are the most common solutions right from our childhood, right from the time we were born, we were drinking mother's milk. So the most familiar example of the solutions, common examples, is the liquid solutions, where we have the liquid as the solvent and a gas is added in a liquid, like oxygen is dissolved in water. The water which we drink is containing a lot of oxygen in it. That is why aquatic species can survive in water, because it contains oxygen. Similarly, a liquid is added in liquid, like ethanol in water, okay, ether in water. The third is solid is added in liquid, like glucose in water, salt in water, sugar, sucrose in water, and so on. The third classification, the third type is solid solutions, where we have the solids as a solvents and the solutes are gas, liquid and solid. Like a gas in a solid, we can remember there is a palladium. Palladium is a solid substance, and in that, on the surface of palladium, you will have the hydrogen gas occupying the pores of that palladium. So in the pores, there are small holes in that palladium metal. On the surface of the metal, there will be small microporous holes, and in that hydrogen gas gets embedded, uniformly distributed. So that's called as the gas in solid. Similarly, liquid also can get mixed in solid. The best example is amalgam. So when we say amalgam, the moment we say use this word amalgam, it means anything which contains mercury plus some other metal, like sodium amalgam, mercury amalgam, and so on. So sodium amalgam, zinc amalgam. So when I mix zinc with Hg, it becomes zinc amalgam. When I mix sodium with mercury, it becomes sodium amalgam, because mercury is a liquid and zinc is a solid. The last example is solid plus solid. The best is copper and gold. We have already discussed in the beginning of this chapter how alloys are helpful for us. So all the alloys will fall in this category because they are a mixture of a metal with another metal or a non-metal, which are both solids. So just remember that this is a keynote given over here, which we may remember that, like for example, like dissolves like polar substances, solutes dissolve in polar solvents and non-polar in non-polar solvents. So this polar, everybody knows, like water is polar, and it has got a dipole, like delta negative negative, delta positive, delta positive. Why we are putting positive negative, we already know, because hydrogen is less electronegative and oxygen is more electronegative. So if I take solvent H2O and I add in it a solute like NaCl, which is also having, it is ionic because it has got plus and minus sign in it. So do you think they are going to dissolve very well? So the answer is absolutely yes, because they are both polar. But if I try to dissolve benzene, in benzene sodium chloride, they will not dissolve, because NaCl is going to be polar or it is ionic, but benzene is non-polar, right? Benzene is going to be non-polar. Similarly, you can take some examples of substances which will dissolve very easily in benzene. Those will be organic solvents. After this, we come to basic concentration formulae, which we can discuss. How do you express the concentration of the solutions? By the meaning of the word concentration is how much solute is dissolved in a solution. So the first formula is mass percent, which is quite simple one, where you talk about how much solute is there in the solution. For example, you have 2% sugar solution. So what does this mean? By weight, W by W, we are going to mention in the bracket W by W, which means weight by weight, or sometimes M by M, that is mass by mass. Percent, which means that how much of sugar you people have taken. You have taken 2 grams of sugar in how much of solution? In 100 grams of solution. 100 grams. Now this 100 grams of course will include 2 grams of sugar also. So approximately let's assume that 98 grams will be of the solvent. When are you going to use this mixture? The formula is whenever you are mixing a solid in a liquid. The one example which I have taken right now. Molarity, we have already discussed in class 11th. It is one of the methods in which the symbol used is capital M. Molarity is nothing but number of moles of solute upon volume of solution in liters. So over here, what is this N? It is nothing but number of moles of solute, remember, upon volume of solution in liters. So this is, the unit is of course moles per liter, because numerator contains number of moles and the denominator contains liters. The unit is moles per liter. It is a volume dependent unit, because you can see there is a volume factor over here. So the volume increases, the molarity decreases. They are inversely proportional to each other. Also, it is not a good method when your temperature is changing drastically, because volume depends upon temperature. So when volume is directly proportional to temperature, when temperature increases, volume increases, and when volume increases, molarity decreases. Then we have another good method. There is another third method, molality. So here there is children often get confused between these two, because in this you have the R and in this you have the L. So be very mindful about what you are using. So here once again I will reiterate, here you are using molarity and here you are using molality. So the difference between the two is just basically that formula. If you notice, here you are using capital M, here you are using small m. Number of moles of solute is common, there is no change, but in the denominator you can see there is volume factor, whereas here in the denominator there is the mass. factor. Okay, so mass of solvent. So the formula is number of moles of solute upon mass of solvent in kg. Number of moles of solute upon mass of solvent in kg. So here we are interested not in the solution's mass but in the solvent's mass. The unit of course is numerator upon denominator is moles upon kg, and it is, the good thing about it is it does not have volume factor, so it is temperature independent, and it is very good method. It is a very good unit because it does not change with the temperature variations. Preferred for colligative properties. What are colligative properties? We'll study in the coming sessions. It is preferred whenever there is drastic temperature change, so this is one of the best units which is unaffected. So friends, next is ppm, that is parts per million. We already discussed this in the beginning of the chapter, parts per million, like how you have percentage. So percentage indicates out of 100 parts, like a student scores let's say 82%, which means how much marks he has or she has scored is 82 out of 100. Similarly, parts per million talks about the out of 10 raised to 6, that is 1 million out of 10 raised to 6. So if it is, let us say 3 ppm, it means that very less amount is present. So this method is exclusively used when the concentration is very less. Trace quantity, you have, like for example you have the pollution level. If you want to express then in a, like how much SO2 gas is present in the air, or you want to express that how much of percentage of a particular salt in sea water. So again the percentage of salt in sea water, sorry, not the percentage, the amount of salt in sea water. So this can be one of the best ways to express in ppm. Alright, so pollen grains, how many pollen grains are suspended in air, that also will be very less in 1 million. So you have to use one, that is ppm method. So that's all about today's session, and we will continue with the next class, the worked example also from NCERT. Till then, you keep studying harder, and bye bye. God bless you.